If there is ambient noise, you turn the mic off. Otherwise, you keep it on. Please. Okay. Good evening, friends.
Good evening, sir.
Yeah. Now, quickly go through the definitions which I have already discussed. I don't want to rediscuss all these definitions. Okay. Now, this is communication system for standard 12. Communication. So, straight away, telecommunications are a means of electronic transmission of information over distances. That is over a distance, correct? The information may be in the form of voice telephone calls, data, text, images or video. Today, telecommunications are used to organize more or less remote computer systems into telecommunication network. Okay, right. So you should understand that we are it's for a distance. There should be distance between the two. Then this telecommunications play a role. Now, a transmitter is an electronic device used in telecommunications to superimpose information on a carrier and produce modulated wave. This modulated wave, electrical signals, is converted into radio waves with the aid of antenna. This is Sankshipt. We will learn about transmitter in detail. So just now you understand the transmitter. We have got a carrier signal. See, for example, carrier signal means, now please all of you listen to me very carefully. See, now I am generating a sound. Okay, can you hear this sound, all of you?
Yes, sir.
Yes, sir. Then I have got the information. What is the information? Hello. Hello is the information. Okay, is the carrier. Hello is the information. Okay. Now you see. See, can you spot the hello in the sound?
Yes, sir.
So what did I do? I superimposed hello on the carrier, and therefore this sound is the modulated wave. Got it?
Yes, sir.
Yes.
So this is the modulated wave. Correct? Now what I have done is, now I have created a mechanical sound wave, right? And a mechanical information, and I have created a mechanical modulated signal, right? So what enters your ears is the modulated wave, has entered your ear. Now if you use your intelligence and filter, that is, you try to see what is the information in the sound, okay, then your ear is discarding the carrier. That is, your ear is discarding sound and only retaining the hello. Okay, so that is called as demodulation. So this is called modulation. Is modulated signal. It enters your ear and your ear only hears the hello. That is, you will discard the carrier and you will only take the hello in that. That is called as demodulation. Got it?
Yes, sir.
So I am modulating, you are demodulating. When the sound enters your ears, you are demodulating to retrieve back the information. You will understand this better and better as we discuss more and more of this. Okay. So a transmitter, I have in lecture told you what is a transmitter, right? Okay. Similarly, a receiver is an electronic device used in telecommunications to choose, select and collect the electromagnetic wave with the aid of antenna. With the aid of antenna, increase the signal to noise ratio, demodulate, retrieve the information and output the information. Okay, so this is the function of the receiver. So receiver will choose, means, see, now for example, say in your class there are many students who are talking, singing and all. Assume that there are many students who are talking, singing and all. Now all those sound is coming to your ear, correct?
Yes, sir.
Now you are interested in the sound of a particular person. You are interested in the sound of a particular person. So what will you do?
We will turn out the other sounds.
You cannot do that in the hall when many of your friends are speaking, singing, speaking, whatever it is. You are interested in the sound of one of your friends, maybe your favorite friend. Okay, so therefore now you will choose that friend. Correct? Hello.
Yes, sir.
And then your ear will see amidst many sounds entering your ear, you will choose the sound of that person, and in your ear when many sounds are entering, your intelligence in your ear is such that you will discard all other sounds from all other people speaking in the hall, and you will only listen to the sound that you want. Clear? See, for example, you have gone to a nice musical concert. The nice musical concert is taking place. Some idiots in that concert, they are sitting and gossiping, talking, and some ambient noise is coming and on. So, if you are a good listener, you will set your ear to the person who is giving the concert, and you will not get distracted by other sounds. Correct?
Yes, sir.
So you choose the person from whom you want to hear, and you will discard all other. You will not heed to all other sounds. That is what I meant by choose and select. And then you collect. That is, it enters your ear, and your ear will process it, and you will enjoy the melody. So only thing is, in the machine, that is in the receiver, it will choose, select and collect the electromagnetic wave. The electromagnetic wave is again a modulated wave with the aid of antenna. Antenna is a device which will convert electrical signal into electromagnetic waves, and also do the reverse. Electromagnetic waves will get converted into electrical signals. Increase the signal to noise ratio. See what happens? So in the receiver, along with the wanted signal, there will be so many unwanted signals that will enter. For example, in the concert that we have gone, you are listening to the person who is singing, and also some ambient noise. So the signal that is entering your ear is signal plus noise, right? Now your ears, your mind is sensitive. You will filter, you will give more importance to the sound coming from the singer and less importance to the other sounds. This is precisely what you are doing, is you are increasing the signal to noise ratio. So in the receiver also we do this. Okay. And then you demodulate, as I told you, demodulation just now, that is retrieving the information, and then of course in a receiver you will do all this and give it to a loudspeaker or whatever it is, right? That is what you do in a receiver. So here the elements of communication system: transmitter, channel, receiver. These are the three elements of the communication system. Is that clear, students?
Sir, one doubt, sir. Sir, now whenever we are sending signal, it always need not be the same signal, sir. So how do we know what to focus on amid all that? Amid all the noise, exactly what to focus on.
What to focus on means?
Sir, like you said, for example, like somebody is singing, so they will be singing in different tunes. So how do we know which tune is the noise and which tune is the signal?
No. That is for you to decide. See, you are lending your ears to the singer. So whatever the singer is telling is the music to you. Why it will be a noise to you? If the singer is singing, it is all a music to you. Hey, you imagine, man, now, one singer is singing and another fellow is talking. Okay, so your ear is getting both, but you are concentrating only on the singer. So you don't bother what others are talking. That is simple. That is how your ear is choosing and selecting.
Sir, now if one singer is singing, sir, then another singer comes up and starts singing. Then how to decide that? Like how can I switch from one singer to the other?
If you don't know how to switch, then you will suffer. That's all. Now don't bring human element into consideration here. Okay, it's up to you. I just gave one small example. Now don't try to build upon that example. Oh, if two singers are singing, both of them are melodious, which one to choose? No, I'm not discussing like that. I just gave you an analogy, one simple analogy where you can distinguish the signal or the message information from other information which is unwanted noise. That's it. No more confusion on this. Right. Okay. So the elements of communication system are basically transmitter, channel, receiver. I hope you got this, students. Now why I am showing this specifically is in your textbook. I hope all of you have got the textbook in front of you. I told you, come and sit with the textbook. I am going to discuss with the textbook only. This diagram also includes one more block, noise. I hope you have noticed that.
Yes, sir.
Figure 15.1.
Yes.
Right?
Yes, sir.
Figure 15.1 to be precise. Right. So you are also seeing the noise there. Correct?
Yes, sir.
Now don't write that noise and all there. It is not a element of communication system. Somehow they have just told general communication system, but that's not right. That is not right. So if they ask you what are the elements of communication system, you should only write these three blocks. Don't write noise and all in that. Clear? Yeah, because I have seen that many students have written noise, and which is really annoying to see the noise and all coming in it. Right. Okay. Now I have prepared a nice illustration for all of you. So just study this diagram, and if you have anything to ask, you can ask. Please study this diagram. Okay, is that clear? Hello?
Yes, sir.
So you can see here, there is a microphone here. So what you see here is sound waves. There is microphone. In the microphone, there is something called a transducer. There are different transducers. In this case, one particular transducer is used. What will the transducer do? It will convert the sound signals into equivalent electrical signals. Okay, hello, did I make it clear? Sound signal into equivalent electrical signal. So if I want to put it in nutshell for you, if the sound signal is like this, okay, this is the sound signal. I am representing it in the form of a wave. Then its electrical equivalent will exactly be having the same shape. Correct? Only thing is the sound is mechanical in nature, right? That is, it has got it is a mechanical wave, right? And the electrical signal is a varying current or a voltage or power. It is varying current or varying voltage. Correct?
Yes, sir. Yes, sir. Yes, sir.
Okay, that is the basic.
What is the same for all the other things will also be same?
Pardon. Once again, come again.
Of that electrical signals, only the shape or frequency amplitude and all will be.
See, listen. See now, you see. If the shape of this and this is same, can the frequency and frequency be different? If the shape, see, I am telling you the shape of this is this, the shape of this is this. Can the frequency be different? Isn't it? See, now try to understand. I will take a photograph of yours in the postcard size. Then I will reduce it to passport size. What changed? Only the size changed, correct? The shape did not change. So the electrical signal amplitude can change, but frequency and other things will not change. Got it? then only the information is retained.
Yes.
Right. Equivalent. I said equivalent. So equivalent electrical signals. So we call it as message or information. Then it is put into the transmitter. We will learn about transmitter in detail. Then there is an antenna. The symbol for antenna is shown like this, and then it is put up in the form of electromagnetic waves, and that goes into the space. Clear?
Yes.
Now, see, now the nearest radio station to us is All India Radio Dharwad. So All India Radio Dharwad has been assigned 3 carrier frequencies. This, and this. What are these? Carrier frequency. I suppose you got it?
Yes, sir.
And then the Department of Telecom will allocate to every radio station its specific carrier frequency and bandwidth and the power. So Dharwad radio station can emit this characteristic frequency. See, characteristic frequency means it is one frequency. The carrier frequency is 1. Okay, but around it you can emit many other signals, but it is band limited. You understood? That means Dharwad station can emit all these frequencies centered around carrier frequency. Got it?
Yes.
And the intensity is proportional to amplitude square. So, and you can even get the power from this intensity, power of the wave. So, the government of India or the telecom department will also allocate a particular power of transmission to every radio station, television station, whatever. Okay, so this is diagram number 1. Now I am showing you Dharwad radio station. Now there is one more radio station called Gulbarga radio station. I suppose you are familiar with this.
Yes, sir.
Yes. So Gulbarga radio station, the Department of Telecom has allocated 2 frequencies. Okay, 1107 kilohertz, 103. These are 2 carrier frequencies allocated to that radio station. Got it? So therefore, each radio station is given its own carrier frequencies. That means now, if at all there is information, they have to superimpose on that carrier only and emit it. They cannot create their own carrier and do that. Got it?
Yes.
Yes, sir.
And again here also the wave is coming out in the form of electromagnetic waves into the space. And whatever is emitted in Dharwad station, it spreads in all directions. Whatever emitted in Gulbarga station, it also spreads in all directions, like electromagnetic waves. I hope you are getting a clear picture of this too.
We can have a restricted area to be covered also.
No. See, now here try to understand this. Now be more practical when you are learning this. How can you restrict the area?
Sir, if by time, as time as it goes to further distances, if we are not able to sufficiently
See, gentlemen. No. See, be practical. Be practical. Be practical. Now, supposing you light a agarbatti in the room. What? Agarbatti. Right? Now, can you limit its fragrance to a particular zone?
No, sir, but after
Tell me. Listen. No, don't ask question. First, answer my question. If you lit a agarbatti, can you limit its zone of fragrance?
Yes.
No, sir.
Yes. Now, say I have lit an agarbatti in this room. So I keep on moving away. So I move up to 10 feet. Still I am able to smell the sound, smell the fragrance. But somebody who is there near me, he says I am not getting any fragrance. Got it?
Yes, sir.
I will move another 5 feet away. Then I will not get any fragrance. But there another friend will come. He says I can still smell the fragrance. It is possible, no?
Yes, sir.
So therefore, what I would like to tell you is, the intensity of fragrance goes on decreasing with the distance. Now, somebody is more sensitive, he can still sense it. So what I am trying to tell you, if you have a very powerful receiver, you can still listen to the sound. For example, I have an ordinary transistor receiver. So with that, I can't listen to Voice of America. But my friend has got a receiver which is very good, very powerful, it's very expensive. He can listen to Voice of America in the same place. Okay, so it depends upon the receiver also. So, but what is important is, well, the Voice of America is available in Hubli also. Correct? So it spreads, it spreads. Okay, that is what is the science. Okay, shall I proceed?
One. So if there are too many radio signals, they are not disturbed.
Good question, good question. I will answer that question. I will answer. My next slide will answer that question. Good student. See, I have developed the theory in a manner in which you know that you can easily, learn. Right? I anticipated this question. Now see, I have got a receiver. Can you see this diagram here? This is a receiver. So I have got an antenna. I have taken example of Dharwad and Gulbarga. Two radio stations, signals are coming, Dharwad and Gulbarga. But there can be many more radio stations. N number of radio stations. Right? There can be N number of radio stations. N number of radio stations. Okay? So all of them are coming to this. So the antenna will receive all the signals. So all these electromagnetic waves will have electrical field and magnetic field, right? So the electric field will, when it comes and hits this antenna, which is a piece of conductor, it will get converted into electrical current. Hello, are you with me? So you will get electric current. Electric current means it is a signal. Electric current means it's a signal. Signal of Dharwad station, current of Gulbarga station. So many currents of different signals will start traveling in the, will be created in the antenna. Okay, can you imagine this? Please imagine this, please imagine. So that means so many signals are there. Now this amplifier, okay, which is also called as RF amplifier, radio frequency amplifier. Now what happens here in this amplifier is, there will be a tuning circuit. So tuning circuit is basically, if you remember when I taught you inductor and all, so assume that I have got an antenna and I will have one inductor and capacitor and a resistor. So here many signals are coming, but many signals means many electromagnetic waves of different carrier frequency. Got it? So Gulbarga's carrier frequency is there, Dharwad carrier frequency is there, then Voice of America carrier frequency is there, Bangalore carrier frequency is there. All these carrier frequencies are there with the information. See, it is like I am going to say hello like this. I said hello. Now another friend will also say hello. Another friend will also say hello, like how I told. But can you distinguish who is telling hello? Say in your class now, Adil, Abhinav, Arun, okay, Aditi, everybody up there, everybody can whistle and everybody will say like this, assume. You can distinguish, no?
Yes.
Yes, sir.
Because each of us are generating our own characteristic frequency. Correct? That is why you are able to distinguish. Clear?
Yes, sir.
Even though all of us simultaneously speak, you can still distinguish if you want to distinguish. Correct? Because each one of us have got different characteristic frequency. So like that, so many electromagnetic signals, electromagnetic waves converted into electrical signals have entered. Now, here I have got a series LC circuit. So at a particular, if I want this station, I want to hear only Dharwad station. Then Dharwad station omega D will correspond to 1 upon root of LD CV. That is, I have tuned this capacitor to particular value CD. I have tuned this inductor to particular value LD, so that now for this value, the signal having this frequency will have least impedance. Correct? Least impedance. Understood? All of you are you clear? That means now, you see, if I see the current here, the current that is flowing here, the current that is flowing here. If I see the current that is flowing here. Okay. So this is frequency and this is amplitude. Okay. Now what I will see is for Dharwad station, the current will have maximum amplitude, and for all other stations, the current is minimum amplitude or very less amplitude. Got it?
Yes, sir.
So this is called tuning, right? So I have tuned it to Dharwad station. So the current or the signal corresponding to Dharwad station is maximum, other signals are minimum. And therefore, I have, and now if I tap this voltage, if I see this voltage VO, this volt, and if I see this, the waveform of this, the waveform of this voltage will have maximum amplitude compared to the waveforms of other voltages. Clear, students? So even though there are hundreds of thousands of radio stations, still I will be able to select Dharwad radio station. If I tune this to LDCU. Now, if I want Gulbarga station, then I will change this inductor and capacitor such that Gulbarga station will be 1 upon root of L Gulbarga C Gulbarga. Correct? Then I will be able to receive this one. Then this will shift. See, this was tuned for Dharwad. Now, what happens? For Gulbarga, it will select the maximum frequency. Got it?
Yes, sir.
Anybody is having any question here? Okay, fine. So this is what happens. So, yes, please.
Sir, now, however, like we are transmitting these through certain medium, no, sir. So, is it possible that they will either interfere?
No. This question already this question you have asked. Already this question you have asked when I was teaching you interference. Okay. Now please understand. See, now in this space many electromagnetic waves are there. They are all interfering. Okay. But they are all, see, you please understand, they are superimposing. See, what is the superposition principle? Each will do its work. They will not get disturbed by others. That means if an electromagnetic wave is going here, it will go. Other electromagnetic waves cannot change its characteristic.
Yes, sir.
Understood? So, Dharwad station electromagnetic wave is coming, its characteristic cannot be changed. Gulbarga is coming, in spite of other waves coming, it cannot be changed. Got it? Point number 1. Now, don't confuse with the interference that you are studying. What is interference? Right? Now, say, for example, two electromagnetic waves are traveling. Right? Say, they are traveling like this. They are traveling like this. Here, if I put a screen, where I can capture the electromagnetic waves, and if they superimpose at that point, what happens? Either you will get a maxima, minima, or something in between that. Got it?
Yes, sir.
But the electromagnetic waves they are just coming and superimposing. They did not get destroyed. Their characteristic did not change. Understood? So let them interfere, but they are not going to change. They will continue with the same characteristic forever. That's it. Okay?
Okay.
Right. So this amplifier is tuned RF amplifier, radio frequency amplifier. So there is a tuning circuit there. Got it?
Yes.
Now, so the signal will come here and this amplifier will only select the required radio station, okay, and then this will send the signal out of this amplifier. So if I have selected Dharwad station, then the signal coming here will correspond to Dharwad radio station. Clear?
Yes, sir.
Now you see, please understand this. This tuning circuit, that is, there is a knob here. There is a knob. So this knob, when I turn this knob here, tuning knob. In radio में tuning knob होता है ना, वो tuning knob. So tuning knob turn होने से क्या होता है? This inductor and capacitor will change. Okay, that is what is going to happen. Now you see, as I tune this, there is also one more tuning circuit here. One more tuning circuit here. There are two tuning circuits. Okay, tuning circuit 1, tuning circuit 2. This tuning circuit is to select the signal. This tuning circuit will change the frequency of the oscillator. See, there will be, in this tuning circuit what I have shown here, there is an oscillator. You remember we discussed oscillators? Hello? We have discussed, one oscillator we recently discussed, no? Transistor oscillator, hello?
Yes, sir.
You remember, we recently discussed this oscillator in the class?
Yes, sir.
You remember? We discussed this oscillator, feedback oscillator and all this. So, this and this can be changed. If you change this, what happens? The frequency of the oscillation will change. Correct?
Yes, sir.
So there will be one such oscillator here whose frequency can be changed. Got it?
Yes.
Ask. If you have doubt, you ask.
Sir, in oscillator, sir, we fast and DC current and it gets oscillated.
What? Come again?
So it is already a AC signal, no, sir? So again, like, how will it oscillate? Like, in oscillator, we pass the DC signal, it was oscillating.
What you said? You
Sir,
remember?
in oscillator, sir, we pass the DC voltage source that was oscillating. No?
See, you are very good in misunderstanding. See, gentlemen, देखो, this is an oscillator. इसमें ट्रांजिस्टर वगैरह रहते हैं. इसको हम VCC देते हैं.
Yes, sir.
Okay? और इसके अंदर I have got an inductor and a capacitor. And some other things are also there. Okay, some other things are also there. Then this has got an output. So VO is equal to Vm sine of omega t. This omega, what is this omega? This is equal to 1 upon root of LC. That is this L and this C. So to whatever frequency I have tuned, I will get that frequency output. That's what
we are supplying VCC over there.
Yes, I am supplying VCC. Yes, I am supplying a DC voltage. This DC voltage is getting converted to AC voltage.
Yes, sir. In this case, here.
Wait. This you understood? Wait. Now, I'll illustrate. So now, cool. So there is one oscillator here. Say, this oscillator, what I am showing here, this is there here. Got it?
Yes.
You learn with me, don't worry. So this oscillator is here. Now, what has happened here in this amplifier? I am getting a modulated signal. Signal here. So this modulated signal has got what? It has got many frequency components. Modulated signal will have many frequency components. Correct? And all these frequency components will have a bearing on the on what? That is, see, this modulated signal, it is modulated on a particular carrier. So that carrier frequency is, say now Dharwad carrier frequency.
Yes.
Come on, everybody say yes again. See, you are irritating me. Hello. See, if you say yes, I will be convinced that you have understood. Else, I will. If you have misunderstood or you doubt, I can clarify. I am very, very serious about ensuring that all of you learn. So, what I will do here is, I will generate. You see here, this signal that is coming here will have like this component omega c. It will have omega c plus omega m. Okay, omega c minus omega m. Like that, I will have many components. Understand? So this oscillator will generate omega c. Hello, are you with me?
Sir, like.
Ask.
That oscillator will be supplied with the VCC and it will convert that, sir?
It will convert. Yes, this is given VCC. This is given VCC. See, these are all active circuits, man. You need to give VCC to all of them. Correct? Achha, that was your doubt. See, for all this you are giving VCC, man. For all this you are giving VCC. Hello? These are all active circuits. Okay? VCC and ground. For all this you are giving VCC and ground. Okay. Understood? That was your doubt, no? This is VCC and ground. Okay.
Sir, now, sir, what is the use?
That I'll tell you. That I will tell you. I know what I will tell you. So at this stage you understand, this has got components, this has got all these components. Appreciated? And this is generating only the carrier frequency. Appreciated?
Okay.
Now, IF stage, intermediate frequency stage. What happens here is, now listen here, what happens here is, this carrier frequency generated by the oscillator, it is mixed with the modulated signal. It is mixed with the modulated signal. Listen, it will mixed with the modulated signal, and what happens here is very important. What happens here is very, very interesting. Here. Okay, what happens there, you know? Hello? What happens here, you know? Hello? Now, here you have got carrier plus modulating. Here there is only carrier. Got it? ऐसा मिक्स होता है कि इसमें जो कैरियर था उसको निकाल देते और सिर्फ आपको मिलेगा इधर मॉड्यूलेटिंग सिग्नल. You will only get the modulating signal at the output. Understand? So that is what an intermediate stage will do. Okay? See, there is a mechanism, man. There is a mechanism. See, there is a mechanism. See, now listen here very carefully. Now listen. I am doing like this. Carrier frequency. Hello. This is modulating signal. Is the modulated signal. Got it? Now your ear. What did your ear do? Your ear did not concentrate on the carrier. Your ear. It only concentrated on the information and it was able to retrieve the information. Got it?
Okay.
So we have to do that here. So for that we need the carrier frequency of the source, which is generated by the oscillator. And this stage, you know, it will filter out the carrier and it will only leave behind the modulating signal. Clear? And this modulating signal has certain envelope and all. I will explain this. So you will detect exactly the modulating signal because this one that is coming out here will have two components. This will distinctly have two components. Which are the two components? Carrier and the modulating signal. The detector will only detect the modulating signal. So you will get only the modulating signal. Here you will get both, but now it is in the form of a composite signal. Here you could not immediately separate the two. Now here it is in a separated form but together. So detector will only remove the modulating signal and this will be amplified and you will get the output. Did you understand this?
Yes.
Everybody there?
Yes, sir.
So now therefore now try to understand. So this is exactly the mechanism that takes place in the receiver antenna. We will study each one of these in detail. We will study the detector, we will study the demodulator, we will study the modulator also. Okay, you will learn. It is very interesting. I will teach you. I am not done. There's a lot of things to be taught. I am just explaining at the block level so that you get the idea in nutshell. Clear? Okay. At this stage, if you have any questions, please ask. Only Adil is telling no. So, good. So, modulator is an important subsystem of a transmitter. Each of the transmitters is allotted carrier frequency, certain bandwidth and transmission power. I have already explained this to all of you. Okay? Now, see, I am explaining this to you aram se so that every stage you understand it clearly. But if you still have doubt, you can ask. Now, there are different types of modulation. Okay? So, you see, now, if you take the carrier frequency, so carrier frequency, let me write quickly, carrier signal, okay, carrier signal. So, I will write the carrier signal like this, C of t. I am giving some name. AC sine of omega c t plus phi c. So now observe this. This is some signal, see, which I am giving the name as C of t. It has got an amplitude. It has got its own frequency and also the phase. Can you appreciate this? Now I will have the modulating signal, MOD. So this I am going to write it as AM sine of omega m t. So can you imagine these two waveforms before your mind's eye? Now observe carefully. Now you see there is something called as amplitude modulation. Now what I mean? See, in this carrier there are three things which you can vary. One is the amplitude of the carrier signal. The frequency of the carrier signal you can change. Now don't start thinking, just go with my play. And the phase of the signal can also be changed. Assume I've got a carrier frequency. Now I can change this, and I can change this. Assume. Good. So in amplitude modulation, what I will do is, I will not change the frequency and the phase, but I will only change this. That is, I will make AC of t as a function of m of t. That is, the amplitude is a function of the modulating signal. Amplitude is made as the function. That means I will vary the amplitude. According to the modulating signal. See, mathematically I have written here, the amplitude of the signal is varied according to the modulating signal, according to this function f1. I hope now you can understand the mathematics. Now here you see, listen, very important. Now you see, students, when you go to higher level, you cannot imagine many physical things. Understand? You cannot imagine, but you should be able to abstract the information from the math model. That is, your understanding should be through the math model only. Don't try to physically start thinking, oh, amplitude model, how will amplitude vary? And all, don't start now imagining. It is not possible. Mechanics, it is possible, but right now it cannot. Now these symbols must be clear. I hope this expression, this equation is clear to all of you.
Yes. Yes.
This equation is clear to all of you.
Yes, sir.
See, now what I have written, the amplitude of this is made a function of time. See, now normally when we write like this, the amplitude is fixed. It is not varying with time. Correct?
Yes, sir.
Now what I have done here is, what we do here is, we make the amplitude vary according to the, see, I'll tell you, amplitude AC is varied according to the amplitude of the modulating signal. According to the amplitude of the modulating signal. I will elaborate this a bit, but right now don't imagine. You should now accept that the amplitude of the carrier is varied in accordance with the amplitude of the modulating signal. The carrier frequency is having, very high frequency compared to the modulating signal. See, carrier frequency is say something like around, it is in kilohertz, 100 kilohertz or so. The modulating is in hertz. Okay. So you can cause the amplitude of this to be varied in accordance with this. So such a variation is called amplitude modulated. It's called we call this type of modulation as amplitude modulated wave. Correct?
Rest of things will be same.
Rest of things will be same.
Yes.
There is another thing called as frequency modulation. So in this omega c will now become a function of the amplitude of the modulating signal. And there is another thing called as phase modulation, where the phase of the signal is made as a function of, is varied according to the amplitude of the modulating signal. Correct? So we get amplitude modulated wave, frequency modulated wave, phase modulated wave. I'll explain this some more details I'll give you. But right now, if you have any question here, you ask.
Okay.
So what did I tell you here? What is amplitude modulated wave? Come on, if you have understood, you tell me.
Amplitude of the carrier wave is converted into a function of modulating wave.
No. Anybody? Amplitude of the carrier is varied in accordance with the amplitude of the modulating signal.
Amplitude of the modulating signal is constant.
Amplitude of the modulating signal is constant. Very good. Right. Good. I wanted somebody to think like this. Okay. See, now what I want to tell you here is, here in this context, what we mean by the amplitude of the modulating signal, you please understand here. What we mean by amplitude of modulating signal is the value of the signal at every instant of time. That is, see, I wanted somebody to have this doubt. No, I will elaborate first. So, say now, this is modulating signal. Clear?
Yes.
Now, this is carrier signal. Clear? This is carrier signal. Got it?
Yes, sir.
So now, when I modulate, now see what happens. Then I modulate. Now, aram se see. So, here, see, what is this? This is the carrier.
Yes.
Its amplitude is fixed. And this is the modulation. Now, when I modulate this, that is, when I modulate this with this, then this fellow will now understood? ये ऐसा तब्दील हो जाता है. अभी मालूम हुआ इसका जो एम्पलीट्यूड है, this will depend upon this envelope. What is this envelope? This is this. Of course, you will not see this white line. I'm telling you. you will not see this white line. Okay. If you see on the oscilloscope, you will see this carrier will be like this. Got it? बारीकी से देखो से this will be like this. You will not see the envelope, but you can now see that this envelope is varied because of this. This is what we call it as amplitude modulated bit. Now the frequency of this is omega c. The frequency of this is omega n. And now you can see this is not a sinusoidal signal. Do you appreciate? Sinusoidal signal means you should have same amplitude. Now this one will have 3 frequency components. Which are those? This will have one frequency component omega c, another frequency component omega c plus omega m, and another frequency component omega c minus omega. Supposing say this is 100 hertz and this is say 1000 hertz, then omega c, so this will have 3 frequencies: 1000 hertz, 1000 plus 100, 1100 hertz, and 900. So this signal is having these 3 frequency components. You have any question, you ask, free. Don't hesitate, come on, because see, you are going to answer very profound questions in the exam. This is very, very superficial what I am teaching. So you must understand this layer 100%. Then I will take you to the next layer. Then to the next layer. Okay? So if you have doubt here, clarify it. And you will not be able to read book and understand this. I am telling you now only. Okay? Please. Trust me. Okay? Why? You ask her. Ask her. Loudly ask her.
So why will it change?
Go. Why will it change? I will answer your question. Okay. Done. Any other question? Please. If you have any question, you ask. Okay. Now I will answer Adil's question. Why will the frequency change? Okay. So here we go. Right. Now I am just giving you a hint. I will explain this in detail. See here. In amplitude modulation, the amplitude of the carrier is varied in accordance with the information signal. Here we explain the amplitude modulation process using sinusoidal signal in the modulating signal. Let C of t be AC omega t represent carrier wave, mt is equal to m sin omega represent the message signal, omega m is the angular frequency. Now Cm of t, what is Cm of t? It is modulated signal. Modulated. Okay, so this will have this form. This will have this form. Now observe this very carefully. See, now here you have got what? AC sin omega t. Got it? Hello, AC into sin omega t. Now here you got sin omega t. This AC is replaced by what? This AC itself is replaced by AC plus AM sin omega t. So you are going to do inside the modulator this mathematics. The modulator will perform this mathematical function. It will take this AC, add it to AM sin omega t, and multiply it with sine omega ct. This is precisely what happens inside the modulator. This mathematics happens inside the modulator. And this mathematics is done using transistors, diodes and resistors. Got it?
So this is when the signal is continuous or something.
Signal is continuous only. Yeah.
Like when you say hello, sir.
Wait. Now, wait. Now I am not discussing hello. I am not discussing hello. Wait. I am not discussing hello. Wait. I'll explain later. I am not done. Now I said here m of t. M of t is what? What is m of t? What is m of t? Just now I used. What is m of t?
Modulating.
Modulating signal. Modulating signal. And this is also the information signal. Or
yes,
the message signal. Got it? Correct? M of t. Now, when I say hello, okay, it is a combination of many modulating signals. Got it? Mr. Arun, Mera hello is a composite signal containing many sinusoidal signals. Did you understand, student? See, now if you make even this sound, see now you can connect a microphone to an oscilloscope and see. You see now great musicians when they say so perfect, very good musician. Okay, now you can see he will get almost a perfect sinusoidal signal. Almost. Great musician. But, now if Arun or Sudheer start saying sir, your sir will look like this. Understood? That means Arun and Sudheer's sir will contain many such signals. It's a composition of many signals. Got it?
Yes, sir.
So now I am, see, now if you want to superimpose hello on this, then you have to impose, then all these frequencies will add on the carrier. Now you can understand. That means now if you have the carrier omega c, so this will also go and modulate this. This will also go and modulate this. All of them will go and modulate. Then I can't write on the board like this. Like this I cannot write. Understand? It will be very, very complicated. Now, as a simple example, I have only chosen one of the modulating signal and causing a modulation of only one carrier frequency.
Yes.
Got it? Clear? Good. See, Nana here. See, I still remember my student days. So, we get these questions. And the teacher thinks, I have conveyed the information to the student and they have understood by whistling and all, I have taught my students. That is not true. Because there can be understanding and misunderstanding. And that is natural to happen in the class. But both of us should be sincere. I should be sincere, you should be sincere. You have a doubt, you must ask. And it's my duty to ensure that all your doubts are clear. That's why I am pausing and aram se teaching. So don't hesitate to ask any doubt. Okay, Arun, is your doubt clear?
Yes.
100%? 100%? So we are taking only one signal and learning. Okay, now if you want to say hello, then you have to take many signals and you have to perform the operation. It will nothing but summation of all these things. Okay?
When I say hello, but
H-E, then...
Listen. Hey, listen. When you say her, you should say her only. Her itself will have so many frequencies.
Oh, okay.
Your her is not one frequency. Your her itself contains many frequencies.
So that one again?
Understood? Yes. So it is very complicated. Okay. See, frankly speaking, students, I'll tell you, this entire science subject, you should experiment and learn. That's the only way to learn. See, right now I have brought a big table here. I have brought many equipments. So next batch of students, I am going to conduct experiments here and explain all the things. Pendulum, motion, RBD, all experiments most of the experiments I am going to conduct. I made a setup. 32 experiments I can conduct. I have purchased a TT table. So in the afternoon I play TT on that. And other time the TT table is used as a laboratory table. And I have put many different cameras here. So next year batch students, some students will be here. They will actually perform the experiment. And that experiment, you can see it on the board. That is the camera arrangement that I have made. And you will tabulate and you will learn. And even this experiment, which communication I am teaching, I have got an oscilloscope. So I will make you to say hello there. And you can see your hello signal on the screen, the waveform. Then you will yourself understand how complicated it is. Understood? So it will be something like this. Okay? Then only you will be convinced. Because these are all like that only. Science is to be taught in the laboratory only. Okay? It cannot be taught like this. I am making my best efforts to make you to learn. Anyways. Okay, so did you get it?
Yes.
Right. So I hope I can continue.
Yes.
Right. Okay. So now let me answer my good friend Adil's question. Right, Mr. Adil. So in frequency modulation, the frequency of the carrier varies, but in phase modulation, the phase of the carrier varies in accordance with the instantaneous amplitude of the instantaneous amplitude. That is important. I missed out. Right? The word I should have used is instantaneous amplitude of the modulating signal. The amplitude and frequency of the carrier signal remains constant, whereas the phase of the carrier changes. Correct? Got it? Hello?
Yes, sir.
Right. Okay. Now, Adil, before I answer your question, so I would like to first understand what is modulation. To a very great extent, I have explained modulation, but still there is something more that you should learn. What is modulation and its necessity? Right? Let me explain this to you. All of you open the book 15.7, section 15.7. All of you open fast. Your NCERT book is the best book, I'm telling you. So all of you are in the view of 15.7.
Yes.
Now I am reading it. I suppose you can hear me and you can also read it. As already mentioned, the purpose of a communication system is to transmit information or message signals. Message signals are also called baseband signals. Message signals are also called baseband signals. Baseband signal means, now you understand. That means now hello contains many signals. Together they are called as baseband signals. Correct?
Yes, sir.
Which is essentially designate a band of frequencies representing the original signal as delivered by the source of information. No signal in general is a single frequency sinusoid, but it spreads over a range of frequencies called signal bandwidth. Now when I say hello, it will contain say about 10 frequencies. Assume hello, it contains 10 frequencies, 10 different frequencies. Together they form the signal called hello. Okay, so this becomes the baseband signal. Right. And range of frequencies called signal bandwidth. Now this word signal bandwidth is important. Now please understand this very carefully. So now, as I told you, this word hello, will contain many signals. M1T. Now M1T, each one is a sinusoid. Okay. Each one is a sinusoid. M2T. Okay. Like this, same M1T. All this. Now what you have to understand, this frequency is omega 1, this is omega 2, and this is omega n. Okay? So this can be something like 100 Hertz, and this can be something like around 900 Hertz. Hello, got it? That means now my hello will contain many frequency components starting from 100 to 900. 100, 101, 105, something. So it will be a composition of all this. Now, that means now my hello has got a bandwidth. What is the bandwidth of my hello? My bandwidth of the hello is maximum frequency that is there in my hello minus the minimum frequency. So my bandwidth is 800 Hertz. Got it? My bandwidth is 800 Hertz. Clear?
Sir, the baseband signal is combination of all this.
Exactly. See, now hello becomes the baseband signal.
Okay.
Now if I am singing a song, supposing I sing a song, full song I will sing. Okay, assume. So if you now see my full song that I have sung for say 3 or 4 minutes, you see what are all the frequencies that are coming out of my mouth. You cannot see, but if you connect my microphone to an oscilloscope, which can convert my sound signals into electrical signals, so you can notice on the oscilloscope many frequencies. Okay. Now say I will sing a full song. So my minimum frequency say is 300 Hertz, right? And my maximum frequency is say something like around 3000 Hertz. So in between I would have generated many frequencies. As I keep singing, I would be generating many frequencies. Hello, are you all with me?
Yes, sir.
Yes. Now, if you want to transmit my complete song, then the amplifiers, the transmitter, receiver and amplifiers should be able to faithfully amplify all these frequencies. Got it? So the bandwidth here, what will be the bandwidth here? The bandwidth here is 3000 minus 300. That will be 2700 Hertz. Right? So now, all these signals, all these frequencies coming out of my mouth are together called baseband signals. Got it? And the highest frequency generated minus the lowest frequency generated becomes the bandwidth of the modulating signal, or the baseband signal, or the information signal. I am not saying that enthusiasm that Prabhu's, Aditi's, Anushri's against someone class.
So this is change from person to person, like.
Yes, it will change from person to person. Correct. It will change from person to person.
So that mic should be capable of detecting all of them.
Gentlemen, excellent. So good. See, if you ask question like that, my life becomes simple. Right? So now you see, now you take mic or amplifier, everything that you use here. All these things, mic, amplifier and all. So here I will say frequency, okay? Frequency versus response. Response means, okay, let me do it like this. Now you take a case of an amplifier, voltage amplifier. This is AV versus frequency. Got it? What is AV?
Amplitude voltage.
AV, voltage gain of the amplifier.
Okay, yes.
Yeah, okay. This is V0 by V. You remember?
Yes.
Now a typical amplifier will have the did you understand? What is this called? It's called frequency response curve. So now we are coming to the practical world. You have made an amplifier. We have learned something about an amplifier. Hello? हाँ. वो amplifier जो आपने बनाया ना, वो transistor amplifier, उसका जो characteristics है, that is, you now see the voltage gain as you vary the input frequency. याद है एक दिन हमने एम्पलीफायर सीखा था, एक सिग्नल सोर्स कनेक्ट किया था, बीन, याद है? And then you have got B out here, याद है?
How will you depend on frequency?
That is the nature, man. That is the nature. जब मैंने आपका एम्पलीफायर सिखाया था, I have not elaborated this. That's what I told. There are lots of things to learn. You have only learned only 0.01% of the amplifier. Understand? You have to learn a lot of things. So I can't teach you everything, in just 3 or 4 classes. And I'm not supposed to teach more than that. But as and when necessary, I told you I will teach. So the frequency response of an amplifier will be like this. Frankly speaking. Okay? Now you see your own voice. Your response will be similar to this. Okay, now for example, you see, now you try singing many songs. Some songs, which are high pitch. So you can sing very well. Okay, but some songs which are very low pitch. See, that is very difficult for me to sing, which is very low pitch. And some songs are very high pitch, that also I cannot sing. In between I can sing. So because my vocal cord has got this frequency, this characteristic. But you see, great singers like Lata Mangeshkar, right? Saigal, if you take those people, they could sing song at very low frequency and also very high frequency. They could take it very clearly and they could control their voice, which it is not possible for me. But understand that your voice, my voice, and the amplifier characteristic, frequency response characteristic is like this, typically like this. So at very low frequencies, the gain is less. At very low frequency, the gain is less. At very high frequency also, the gain drops. In between only, you have got the frequency, the gain is constant for a range of frequencies. This is called lower band, lower frequencies, very high frequencies, and mid band frequencies. Got it?
Yes.
This is the nature. See, that's what I'm telling. See, this chapter communication is introduced to connect you to the next level, next engineering level. So still now, everything was idealized. Assume no friction, assume the transistor is, the diode is an ideal diode, all that we were doing. But now come to the real world, okay? So the frequency response characteristic will be something like this. So for different people, this characteristic will be different. See now, for example, now this is for an amplifier I have shown. Now if you take the similar characteristic for a mic, okay? So for a mic also you can say output divided by input for a mic. So the mic can also have something like this, or it can be like this, or some mic can be like this. It is quite possible. Got it?
Yes.
Great. So I think I answered your question.
Yes, sir.
All right. Okay. Now let's continue reading. Suppose we wish to transmit. Now I'm coming back to the book. Suppose we wish to transmit an electronic signal in audio frequency range, baseband signals less than 20 kilohertz, over a long distance directly. Let us find out what factors prevent us from doing so and how we can overcome this. के सेंटेंस का मतलब समझा आपने? देखो मैं क्या करता हूँ, अभी माइक लेता हूँ, तो मैं गाना गाना शुरू कर देता हूँ और माइक से जो इलेक्ट्रिकल सिग्नल्स आ रहे हैं ना उसको एम्पलीफाई करके एक एंटेना लगा के छोड़ देता हूँ. ठीक है? हेलो, मॉड्यूलेशन नहीं करूंगा मैं, ऐसा ही कनेक्ट करके छोड़ूंगा तो क्या होता है? ऐसा कर सकता हूं क्या मैं? हेलो, कैन यू इमेजिन? हाँ, so can you imagine that? That is, I just have a mic. You took time to say yes. See, your time only will get wasted because I will feel that you didn't understand. So this is a mic. So from the mic, so I am thinking. So the mic wire is coming. I will connect it to one amplifier, and then I will give it to an antenna. Okay. So now. Electromagnetic waves are generated. I am not modulating only. Can I do it? The question. That is what the question they ask. And if you try to do it, what are the consequences? Hello, are you with me? Now, can I do it?
Yes, you can.
What is antenna? I taught you in the last class. What is that antenna I taught you last class? Do you remember? What is antenna? Basically, what is an antenna?
You convert the electrical signal into equivalent electromagnetic force.
What is that? Physically, what is an antenna? Basically,
in a straight wire, sir.
Straight conducting wire. Correct?
It is
Straight conducting wire. Correct? Straight conducting wire.
Yes.
Now, you remember yesterday I told you, supposing you connect a signal source like this of Vm sin omega t. Will this signal get converted into electromagnetic waves?
There is a condition for lambda.
What is the condition?
It should be minimum lambda plus 2.
So you were active in the class. So this should be greater than lambda by 2. Correct? Now you see, as a human being, when I am singing, my frequencies here is something like 300 Hertz to 3000 Hertz. Okay, now this is the frequency I am generating. If you observe it, if it is a lady, she can go up to 5000 Hertz. Her voice is more shriller, she can go up to 5000 Hertz. But as a man, this is the frequency. Okay, now assuming 5000 Hertz. So 5000 Hertz, what is the band? What is the wavelength? So this is the frequency. What is the wavelength? 3 into 10 to the power of 8 divided by 5000. C by F. Say yes or no? No. So what is this? So 3 into 10,000 into 10 to the power of 4 divided by 5000. So 5 is the 5. So this becomes what? 60,000 meters. Correct? Lambda will be what? 60,000 meters. Correct?
Yes.
Now minimum antenna length should be 1/4 of. So 60,000 divided by 4 will be what? 15,000 meters. That means how much? 15 kilometers. That means if you want to do like this, you must have an antenna whose length is only 15 kilometers. Idhar se Sattur tak. From Hubli to Sattur, that much wire you take and you make it to stand vertical and you sing. हो सकता है क्या? प्रैक्टिकली हो सकता है क्या? नहीं हो सकता है. ठीक है ना? अगर आपने ऐसा वायर बना सकते हो और खड़ा कर सकते हो वर्टिकली तो कर सकते हो. नहीं हो सकता. मालूम अभी? So therefore you cannot directly send a signal like this. Point number 1. Got it? So therefore now you understand. Now you understand. So your frequency, maximum frequency, I took it as 5000 Hertz. So 5000 Hertz. This is the baseband signal. Baseband signal. Now when you modulate it, what are you doing? You are taking a signal, say something like around 10,000 Hertz. 10,000 Hertz. This is what? This is the carrier. On this, you are superimposing this. Hello, are you with me?
Yes, yes.
And therefore, when you superimpose on this using amplitude modulation, the resultant frequency of the modulating signal, will be what? Will be 10,000 hertz, 10,000 minus 5,000, 10,000 plus 5,000. Correct? Hello?
Yes, yes.
But I have chosen this one here 5,000 hertz, 10,000 hertz. So you can take it still higher than this. Okay, you can take it. I have chosen 10,000 hertz here. So you can see that you have converted your sound, your signal from 5,000 hertz to, you are superimposed it on 10,000 hertz. That means now your antenna length will now become half. But still, if you use higher carrier, then it can still become smaller and smaller. So now, if the carrier is having say 1 megahertz, then what will be the carrier? What will be the antenna size? Antenna size will be what? 3 into 10 to the power of 8 divided by 1 megahertz, 10 to the power of 6. So your antenna size will be 300 meters. So 1/4 of this will be what? 75 meters. So if your carrier is having 1 megahertz, then the size of the antenna will only be, minimum size of the antenna necessary will only be 75 meters. Even so, 75, see, I am telling you, if you want to put a straight wire. So therefore, there are different types of antennas. Okay, you can convert it into helical antenna and all that theory is there. So one thing you have to understand from this is that if you increase the carrier, then the antenna size will decrease. Correct?
Yes. Yes.
So now you see 15.7.1. Okay? Whatever I have explained, it is here. Therefore, the need for translating the information contained in the original low frequency baseband signal into high or radio frequencies before transmission. Correct? So there is a need for that, and modulation is what we do. So a modulator will translate a low frequency message signal into a high frequency same message signal, into another signal which is at high frequency but containing the same information.
Yes, sir.
See, now if I say hello, hello. So if you collect all the frequencies, it will be around my hello. It is just around 300 to say 500 hertz. Hello, are you with me?
Yes,
so it's only 500. Now you see. So the same hello is there, but it is translated into high frequency, something like around 2000 hertz. Contains 2000 hertz. Correct? So that is precisely what we mean by frequency translation. Okay, so the first paragraph is understood. Done? Next. Effective power radiated by the antenna. So antenna will convert the electrical signal into electromagnetic waves. So yesterday we have discussed about the conversion efficiency. I suppose all of you remember. Now you see. Effective power radiated by the antenna. A theoretical study of the radiation of linear antenna, length L, shows that the power radiated is proportional to L by lambda square, where L is the length of the antenna and lambda is the width. This implies that for the same antenna length, the power radiated increases with decreasing lambda, that is increasing frequency. Hence, the effective power radiated by the long wavelength baseband signal would be small. For a good transmission, we need high powers, and hence this also points for the need of using high frequency transmission. Correct? L by lambda. Lambda is the highest, the lambda corresponding to the highest frequency in the baseband.
Yes, sir.
Next aspect is mixing of the signals from different transmitters. This I have already explained in the first diagram. Clear? Sorry. So in this only I have explained. Correct? Here you see. Here see Gulbarga and this. So here you have got both Dharwad and Gulbarga coming, they are mixed. Right? But even so, if I had not used modulation, then both Dharwad and Gulbarga would be coming, then your receiver will not be able to select Dharwad and Gulbarga. Everything will be same. Okay? Now, if two people are making sounds and they have got same characteristic frequency, say two twins are there and they are both making noise, their character vocal cord is giving same frequency, then you will not be able to distinguish who is who. You are able to distinguish the sound from your friends in the classroom because each one of us have got distinct vocal cord, distinct characteristic frequency. Otherwise, it is not possible. So, therefore, modulation will ensure that you are able to distinguish between the signals coming from two different transmitters. Hello, students. Is it clear? Got it?
Yes, sir.
Yes. So, you see, this 15.7.3, this whole thing I have explained for almost an hour for all of you so far, and you can see here different modulations. Okay? Now, you see figure 15.7. Can you see 15.7?
Yes, sir.
So, here you see there is a signal given there, a sinusoidal signal and a pulse shaped signal. Now, what they are showing is the message can be in the form of a sinusoidal wave or it can be in the form of a pulse also. Got it? Now, you know about a sinusoidal signal. You know frequency, amplitude, time period, wavelength and all those things. When you deal with pulse, so you have got pulse amplitude, then pulse duration, okay, all this becomes significant. Okay, that is the essence of this 15.7. Now come down here to figure 15.8. Hello? Now you can see 15.8, C of t, that is carrier frequency, carrier signal, M of t, the modulating signal or the baseband signal, right? Or the message signal. Now you can see an amplitude modulated wave. Can you see? Cm of t, hello, for AM. But remember, this envelope that they are showing here, that envelope will not be there. You understood? That envelope, so here you see, actually the signal, amplitude modulated signal will be like this. Okay, this envelope is similar to what? It is similar to the modulating signal, but actually it will not be there. If you see on the oscilloscope, you will only see this signal. Okay, you will not see the envelope. Got it? I said got it. Then for FM signal, you can see I am completing after explaining this diagram. Just hold yourself. If it is frequency modulated, then the carrier will start looking like this. And if it is phase modulated, the carrier will start looking like this. Correct?
Yes, sir.
Now, similarly, the significant characteristic of pulse are pulse amplitude, pulse duration or pulse width modulation, pulse position modulation. Okay? Hence, the different types of pulse modulation are pulse amplitude modulation, pulse duration modulation, pulse width modulation, pulse position modulation. In this chapter, we will confine to only amplitude modulation. Correct? So, there are different modulations. So, for you, only amplitude modulation is there. We will discuss that in detail tomorrow. Okay, friends?
Yes.